All right, Chapter 4, Free Response Review. Got a couple proofs, got some SAT type of problems, some tougher algebra involving systems of equations and some factoring, so all kinds of good stuff. So let's get after it. Number one, we have a proof here. Let me just kind of scroll down to where I can get all the pieces in. So we set up our proof, and again on the test, make sure that you write everything out. I'm going to not write everything out on here just to save some time. So for step one, you're just going to basically put all of this given information right here, and you're going to say given, and let's mark what we have. So we do have AC is congruent to BD. Now I would not start marking other congruent pieces until you state it in your proof. So this one's already been stated, so I just marked it. Now I'm going to start operating off of my clues here. So the first clue is E is the midpoint of CD. All right, so this clue right here, E is the midpoint of CD. Well, that tells me CD got broken in half. So that tells me that segment CE must be congruent to segment ED. And how do I know that? Well, that's the definition of a midpoint. So definition of a midpoint. Now that I've stated it in my proof, I can go ahead and I can mark it. It said CD bisects AB. So CD bisects AB. So that means AB got cut in half as well. So I think from that clue, I can say that AE must be congruent to segment EB. How do I know that? Well, because I know what a bisector is. So definition of a bisector. So I mark that. And really, I'm pretty much done now. I have three sides. So I'm going to go ahead and I'm going to shut the proof down, and I'm going to say triangle AEC must be congruent to triangle BED. And my reasoning is side, side, side. Now, somebody may have done this proof a little bit differently. At some point, you could have did the angle 1 equals angle 2 and did vertical angles, and that may have given you a side angle side. So that's an option, but I don't think it was necessary. All right, scrolling down to the next proof. Got some parallel lines, so I know alternate interior angles are going to come into play here. So step one, given, copy all the crap down. I do have a freebie. I do have WX is congruent to ZY, so I do have a side to start with, so that's nice. Well, let's start going. First thing I spot right away is I see that I have a shared side. Now, you don't have to do this first, but I'm going to just go ahead and get it out of the way. I'm going to say that XZ is congruent to itself. And my reasoning is that is the reflexive property. Okay, reflexive property. Now it says, I got to wonder, why did they give me this clue? Why did they tell me that WX is parallel to YZ? So when I have two parallel lines, I do have alternate interior angles. So I think we can go in and I think we could say that this angle 1 and angle 2 have to be congruent to each other. And I probably shouldn't have marked it because I haven't said it yet, but I'm going to mark it. I'm going to say angle 1 is congruent to angle 2. How do I know that? Because parallel lines make alternate interior angles congruent. Really, as long as you say something about alternate interior angles, you're good to go. So now I should have all three pieces. It's a little bit cluttered because I have those parallel marks, but when I just focus on, let's say, the top triangle, what I have for markings is I have a side, and I do have the included angle. So I think we have enough information to say that triangle WXZ must be congruent to triangle YZX. And my reasoning is side, angle, side. So not too bad, a couple short proofs there. So now we get into some solving problems. So let's take a look at these. Right away I spot some isosceles triangle markings, which means these two angles should be equal. So I pretty much just have y now. Y is 52 degrees. That was easy. But now I need to get x. So I need to get that vertex angle on the top. So far, 52 and 52 are 104. And subtract from 180 leaves me 76 degrees for the top. Now that's not x, but it'll help me get x, because 14x plus 6 needs to be 76. Subtract 6 from both sides. Divide, divide. And boom, I got x equals 5. All right, over here on number 4, again, I notice these two sides right here, this blue side and this blue side, are equal, which means these two base angles right here have to be equal. But I don't have them yet, but I can use the 124 to jump in because it forms a straight line. So if I do 180 minus 124, that's 56. Which should allow me to find the bottom two angles. And actually, I could use the exterior angle theorem because I know that 124 has to equal these two added together. And I know they're equal, so pretty much I can divide it in half. I can split it up. Divide by 2 gives me 62 degrees for each of those. So now we have to 180, we're equal. Now I just got a couple equations to solve. 2x is 62, which makes x 31. And then 14y plus 6 also has to be 62. So subtract 6 from both sides, divide both sides, and boom, we got x and y. Money. All right, let's go down. So now we have a coordinate grid problem. I think I'm going to try to shrink this one down just a little bit so we can see everything. So let me just try to zoom out a little bit. Try this dynamic zoom. All right. So actually, how do I get out of dynamic zoom? Maybe I just got to tap on it again. I don't know. Never really done it. Marquee zoom, I don't know. We'll see what's going to happen. But I'm going to move this down. And so let me get my dots on the grid here. So it says triangle BOY has vertices at 2, 1, 5, negative 6. So let me see. I have 2, 1, 5, negative 6, and then 5, negative 2. And we're going to label this. So we have B, and we have O, and we have Y. And I'm going to connect them together. All right, so I got my triangle. And first step is classify it by sides. So I got to figure out how long it is. Because remember, if I do scalene, that means there's no equal sides. If I choose isosceles, that means there's 2 equal sides. And if I choose equilateral, there's 3 equal sides. So I got to figure out how long these sides are. So what I'm going to do is I'm going to use the Pythagorean theorem to calculate that. So let's just kind of go on here. Let's get BY first. So BY is a little 3 by 3 triangle. So I know that BY is going to be the square root of 3 squared plus 3 squared, which is the square root of 18. Now, I could go ahead and I could figure out what that is, but I don't really care as long as if somebody else is the square root of 18, I'll know they're equal. So I don't really need the decimal. Well, OY, the length of OY, well, that one's just a vertical line. I can count that one. That one's 4. So that's different. The other one's going to be 4 point something, something, something. Well, then when I want BO, that's a 3 by 7. So to get BO, I got 3 squared plus 7 squared, take the square root, and that's 9 and 49. That's a square root of 58. So right now I can see that I have three different sides. You're different from you, from you. So final answer to this question is scalene. It's not isosceles, not equilateral. Now, part B, is this a right triangle? Well, I could pretty much look at that and tell you that it's not a right triangle. So probably wasn't the greatest question for a right angle question. I should make it look at least somewhat close. But how you do these are you need to compare the slopes. And if it's a right angle, okay, if it's 90 degrees or perpendicular, we basically need opposite reciprocals for slopes. So when I look at BY, well, BY has a slope of -1. YO has a slope that's undefined because it's a vertical line. And BO drops 7 and runs 3 to the right. So none of those slopes are opposite reciprocals. So no, it is not a right triangle. All right, moving right along. Ooh, undo. How do you undo? Not sure. All right, now we move into the SAT questions. So let's kind of see what we got going here. Looks like I have a couple of isosceles triangles. It says, note, figure is not drawn to scale. So down below it says, two isosceles triangles are shown above. If 180 minus z equals 2y, and y equals 75, what is the value of x? Well, if you're telling me y is 75, that should help me out here because it says 180 take away z equals 2 times y, which is 2 times 75, or 150. So that opens up the door to tell me what z is. It looks like z has to be 30. So that got me the clue to at least be able to find z. So I have 30 degrees over here. Well, if I kind of just blow up this triangle, and I know that this side equals this side, I know that these base angles have to be the same. So if you're 30, that leaves 150 left, and I got to split up that 150 evenly. So that means you're 75 and you're 75. And now to get x, I can just subtract from 180 to get this piece out here. So I believe x is 105 degrees. You also could use the exterior angle theorem. Remember, this outside angle right here should equal those two added together. So just another way to get it. Number 7 in the figure above, MQ and NR intersect at point P. NP equals QP. So let me mark that down. N to P equals Q to P, but there's no triangle there, so that really doesn't help me. And MP and PR, that helps me. So now I have MP and PR, which tells me that these two bottom angles have to be the same. Hopefully that'll help me out here at some point. What is the measure of QMR? Well, QMR, Q to M to R, means we really want to figure out how many degrees that is. So that's kind of our answer to the question. Well, let's see what we got. I see 2 out of 3 over here, so that's 130 degrees subtracted from 180. That gives me 50. Kind of stuck there. I can play vertical angles and get the 60 over here. I can play a linear pair and get me 120, which I think is what's going to help me out. Because now if I just focus on this triangle, I have a vertex angle of 120 at the top. These two have to match. Well, there's only 60 degrees left. So if I divide it by 2, it should be 30 and 30. So I think the correct answer here is going to be 30 degrees. Number 8. Looks like we got some parallel lines. So let's see what that's talking about. In the figure above, L and M are parallel. So that's going to open up the door for some alternate interior angles, corresponding angles, all that good stuff. It says y is 20. So there's a 20 degrees. And so since we're doing parallel lines, this needs to be 20 degrees because they're corresponding angles. Z is 60. Well, this one's pretty easy. So now the value of x, 20 plus 60 is 80. Subtract from 180 tells me that x needs to be 100. Correct answer B. Number 9, x is this little sliver right here, and that's what we're trying to find. So I need to figure out what that little angle is. So ultimately, if I can, I'm going to blow that little triangle up. If I can kind of get, this RV triangle down there in the little bottom corner, if I can get some other information in there, that should be able to help me out. The clue, don't miss the clue, RTTU. So that means RT has to equal TU, which means that this angle needs to match that angle. All right? So that gives me another little piece of the puzzle. So 114, that's the vertex at the top. If I subtract from 180, that gives me 66. Split it up evenly, gives me a 33 and a, right down in there, 33. It's kind of why I like to make it bigger. Still don't quite have what I need, and this is kind of the big move on this problem. Focus on this triangle right there, because if I can get this angle right here, that's going to help me out, because that and x has that up to 180, and I see that I have a 33 and a 60 and a 31, so that's 64. So to see what's left, it looks like I got 116 left. So there's 116, and if that's 116, to play the straight line game, jumping over, it looks like this has to be 64. Also, you could have realized that this is just an exterior angle with these two as being the remotes, and you could have just added them together. So that's another option as well. What else we got? The last SAT, number 10, is figure not drawn to scale, AB, AD intersects, blah, blah, blah. X is 100. Give me a number. Sweet. Find Y. Pretty straightforward. 100 plus 20 is 120. Subtract from 180. Vertical angle in. I'm back to 100 over here, so it looks like I'm missing 80 degrees. So that one's pretty easy for an SAT. All right. Now, algebra problem. And this was on the 4-6 practice on the challenge problem, if you want to go back and get a look at it. But I see these little tick marks, so that means these sides are equal. So that means that x squared equals x plus 20. Now, this is a quadratic. You can't just, get x by itself and solve it. So to solve a quadratic, my go-to method is I'm going to try to set it equal to 0, factor it out, and then use the zero product property. And I'll kind of walk you through these steps. So first, let's set it equal to 0. Let's subtract x and subtract 20 to put it all on the left-hand side. So now I've set it equal to 0. So step 1 is accomplished. Now I need to factor. This is the hard part. So now I need to factor and figure out what two things can times together to make that expression. And the game is kind of played where I need to multiply. So this is where you want to start. I need to multiply to make a negative 20. Well, the ways that I can do that are I could do 1 and 20, 2 and 10, 3 doesn't go in there, or 4 and 5. Now I got to be careful with my negatives. To make a negative 20, one's got to be negative, one's got to be positive. But at the same point, I need to add to make negative 1. So I need to find one of these combinations down here that add up to be negative 1. I think if I play my cards right, I think if I do that, here's the combination. Now that's not the answer, but that's the combination that I can put inside these parentheses. So x plus 4 times x minus 5. If you were to use FOIL or double distribute, it would check out. Well now, so the factoring's done. I've got my two factors. Now I'm going to use the zero product property. And all that said is that if something times something equals 0, one of them's got to be 0. So when is x plus 4 equal to 0? Well, that occurs when x is negative 4. When is x minus 5 going to be 0? Well, that occurs when x equals positive 5. So those are my two answers, negative 4, positive 5. You could always double check. So if I stick negative 4 in here, negative 4 times itself is 16. If I put negative 4 in here, I get 16. Life is beautiful. If I try 5, 5 squared would give me 25. And 5 plus 20 will also give me 25. So now you can see that there are two answers that can make that triangle true. You're always going to have two answers when you have the x squared in the equation. That 2 kind of tells me there's going to be two answers. All right. What do we got next? So we have a couple lines that are parallel to each other. So I know that this is parallel to this, which tells me I got some angles that are equal. Right now, I'm going to just finish that up in the top. I have an 80 and a 60 is 140, which means to get 180, that's got to be 40. Well, now I kind of see that this 60 needs to equal this because they're corresponding angles. So I see that 4x plus 2y has got to equal 60 degrees. But then by the same token, this x minus 2y has to equal 40 degrees. So this is why I said that you're going to want to use elimination or substitution to solve the system. Two equations, two unknowns. I am always preferential to elimination. It just, to me, seems easier. Elimination basically means that I'm going to combine the two equations. And what I'm hoping to get is some opposites that'll eliminate. And I notice right here, if I add these two together, I'm going to get 4x plus 1x is 5x. And here's where the elimination happens. Positive 2y and negative 2y disappear. So I set this one up nice for you so that the opposites were already there. Sometimes you have to multiply a row on your own to get opposites. So if I were to, this is just a thought bubble, not anything to do with this question. But if I were to do like, 2x minus 3y is 8 and 4x plus 2y equals 1. Those two don't line up, like there's no opposites. If you add them together, you're not going to get anything to eliminate. So this would be somewhere where you might want to multiply the top row by negative 2, because then I will get negative 4x, positive 6y, and negative 16. And now I could add the two rows up to get something to eliminate. But I made this one easy, so you didn't have to go through all that. So I get 5x equals 100, which means x equals 20. Now, once you get your x, you can go back into either equation, solve for it to get y. Maybe I plop it into this part right here. So instead of 4 times x, I'm going to do 4 times 20 plus 2y is 60. So that's 80 plus 2y is 60. Minus 80 from both sides. Get negative 20. And divide. And we get y equals negative 10. So those are my answers. X equals 20 and y equals negative 10. I do believe if you plug those in, everything will check out and life will be good. All right, hopefully that helped you out. It cleared up some things to get you ready for the actual test. Be sure when you're done with this assignment to submit the PDF into Schoology. I would rather not have them in my emails. It just fills up my email box. So Adobe Scan is a really good app to take pictures of your pages and then put them into a single PDF. It makes my life easy, and I appreciate it. See you.